Alright, in this video we're going to look at about 10 more questions on the final review. We have some more quadratic, a little bit larger degree polynomials, I think a couple of application problems, inequalities, and then I think we end up with an exponential equation, equal bases, equal exponents. So here we're going to look at 3x squared plus 23x plus 30 equals to 0. We can certainly do the quadratic formula, but if I can get away with factoring, I'm going to go ahead and factor it. So we're going to do the AC method. So 3 times 30 is going to be 90, and I'm going to go through the list of my factors of 90. So I just start dividing by 1, and then 2, and then 3. 4 won't work, but 5 does. And actually that's my winning pair, 5 and 18. And so what I can do is I can write 23x as some combination of 5x plus 18. It just depends on, well, the order doesn't matter. Just one order works. So we'll do 5x plus 18x plus 30 equals to 0. And then 4 terms, we'll go ahead and factor out the GCF of the first 2 terms. So we're going to do a factor by grouping, and then the 6 out of the second. And then we got matching factors of 3x plus 5, so we'll factor those out, and then we're left with x plus 6. And then we'll go ahead and set each factor equal to 0, so we get x is equal to negative 5/3, or x is equal to negative 6. Okay? Alright, let's try another one. Okay, in this one we have x to the 4th minus 1 is equal to 0. So it is a larger degree polynomial, so certainly you can do the rational roots theorem on it. However, it's set up so that it'll factor pretty nicely. It is a difference of squares, but it is, oh, that's not very good x. It is x squared squared, which is x to the 4th. So that's our square there. So it looks a little different. Okay. Alright, so this is x squared minus 1, and then x squared plus 1 equals to 0. The x squared minus 1 is a difference of squares, so we can factor it again. The x squared plus 1 is not a difference of squares. We don't have a factoring formula. I guess we do, but not one that we commonly use. Anyways, so this gives us x equals 1 for the first factor, or x equals negative 1 for the second factor, or x squared is equal to minus 1. And then to undo that square, we're going to take the square root. Don't forget your plus and minus. And if we take a square root of a negative in this context here, we're going to get the imaginary unit I. So our answers for the first two here are 1 and negative 1. For this one over here, we're going to get plus and minus I. So we can write that as x equals plus and minus 1 and plus and minus I. Those are the 4 roots of this polynomial. So we're going to take a look at another higher degree polynomial, and certainly you can try to do the PQ theorem, but it's not going to work on this one because of the roots that are involved here. So we're going to have x to the 4th plus 13. It should be x squared. Let me see if nope, I didn't write it in. So we need to put that on here. So it's x to the 4th plus 13x squared plus 36. And so this is in quadratic form, so we can go ahead and factor it. To make an x to the 4th, we need an x squared times an x squared. And then 9 times 4 will be 36, and when I add them I get 13. Okay. And then we'll set each factor equal to 0, so x squared equals negative 9, or x squared is equal to negative 4. To undo those squares, we'll take the square roots, and don't forget your plus and minus. We are taking square roots of negative, so we will get I. So we'll get 3i and 2i as our solutions to those polynomials there. Alright. So moving on, I think we get into the inequalities here. So let's go ahead and see what we got going on in the next one here. Alright, so we got x plus 7 over x minus 1, and then that is less than or equal to 0. Now, one of the things that we have been doing is, if I have fractions, typically I want to clear the fractions, but that's with an equal sign, and that's okay. But with inequalities, if I multiply or divide by negative, I may have to flip the inequality. Because I don't know what x minus 1 is, I don't know if I need to flip the inequality or not, so I'm not going to do it that way. The method that we used in class is we found the boundary points. Some classes might call them cut points. That's essentially finding the x-intercepts and the vertical asymptotes, and certainly in this case. So the shortcut is the top equals 0 and the bottom equals 0. Okay, and the bottom equals 0 is also going to be a restriction, but it is a boundary point in addition to being a restriction. So x equals -7 and x equals 1. Those are our boundary points because that's what makes the top and the bottom 0. And now our restriction is x cannot be 1, and that's actually going to be a vertical asymptote. And because we're doing a less than or equal to, that usually is going to involve brackets, but 1 is not going to get a bracket because it's a restriction. So we're going to go ahead and make that comment here. So x equals 1 is a restriction, so no bracket. Okay. So we're going to draw our number line. That's going to help us with our interval, drop our boundary points. Then I'm going to go ahead and draw this in as a simulation that it is a vertical asymptote. And then what we do is we test your favorite number in each interval. Okay, so we're going to test -9, and we just plug it into the inequality, and we're looking to be whether it's true or false. Okay, so we're going to go ahead and work that out. -2 on the top, -10 on the top, bottom, reduces to, well, not quite 1/10. It reduces to 1/5, and that's not true. Okay. All right, so that's false. So we're going to throw that answer out. So we just cross that out. Okay, and then we'll pick a number between -7 and 1. So 0 is a good one. Okay, so 0 plus 7, 0 minus 1, and we get 7 over -1 is equal to -7. And is that less than or equal to 0? Yes, it is. So that is true. So we're going to save that interval. And then we'll try 2. 2 plus 7 over 2 minus 1. So 9 over 1 is equal to 9. Is that less than or equal to 0? That is false. So we're going to throw out that interval also. So we only have one true interval, and it is starting at -7 and ending at 1 because of the restriction here. We have a parentheses at 1. Because of the less than or equal to, that's why we have a bracket at the -7. Okay. So I think we're going to do a polynomial inequality, and then we're going to do a compound inequality in a moment here. So polynomial inequality, basically the same setup. There's not going to be a bottom, but everything's on top. And so we're going to go ahead and find our boundary points, which means we're going to go ahead and factor. And we get x plus 10 and x plus 1 less than 0. And that gives us our boundary points, and the cat's shedding all over the place. You might be able to hear him purring. I don't know. He was leaving me alone all the rest of the day today, but as soon as I start making a video, it's time for attention. Anyways, so let's put our boundary points in. And we'll test -11. We'll just throw it into, I like to put it in the factored version here because it's a little bit easier to do the computations. Okay, and to get +10, the inequality wants less than 0. That's false. So we'll throw that one out. We'll test -2 and do the same thing. Just run it through our inequality, and we're looking for, does it satisfy the inequality or not? Okay, so 8 times -1 is -8. That's less than 0, so that's true. So we're going to go ahead and take that interval there, -10 to 1, and then 0. So 0 plus 10, 0 plus 1, and that's 10 times 1, which is 10. That is not less than 0. That is false. And so we'll throw out that interval also. And so our solution is going to be -10 to -1, and we didn't have a less than or equal to or a greater than or equal to, so strict inequality. So we used just the parentheses. Okay. All right. Now we're going to look at a compound inequality, which has 3 sides. So we have negative 3 less than or equal to 5x plus 7 less than 9. And so we're going to solve it no different than how I would, well, let's try not to write with the eraser. Negative 3 less than or equal to 5x plus 7. So what we would do is we would subtract both sides by negative 7, and then we would divide by 5. Okay. So we're going to do the same thing. We're going to subtract 7 and divide by 5, but we're going to do it on the other side. So we do it to all three sides. Okay. So we're going to subtract 7 from all three sides. So we have minus 10 less than or equal to 5x less than 2. Divide all three sides by 5. We didn't divide by a negative, so we don't need to flip the inequality. So negative 2 less than or equal to x less than 2/5. So what does our solution look like? Probably need to move this scratch work out of the way. Bracket at negative 2 and parentheses at 2/5 to correspond with our inequality. Oops, well, I just want to really draw with the eraser, I guess. Corresponding to our inequalities there, okay? All right, so I think that's it for inequalities. Now we're going to get into some applications. So we're going to look at uniform motion. That's the distance equals rate times time. We're going to look at a job problem. Rate times time is equal to one job. And then the last one is a mixture problem. Okay, so let's go ahead and look at this. So maybe we'll speed it up a little bit. Okay, so it says a bus travels 320 miles in the same time a car travels 280 miles. The car rate is 80 miles per hour less than the bus rate, so it's a little slower. And we're going to find the rate of the bus. Because we're talking about speeds and distances and times, that's going to be our distance equals rate times time. You may have seen the triangle in class before, distance on the top, rate and time on the bottom. So if you want to solve for one of the variables, you just put your finger over it. So if you want to solve for the distance, it's cover up the d, and then you got r times t. If you want to solve for the time, you cover up the t, and you get d over r. Okay, and that's what we want here. That's the key to this problem, is they say the same time. So that means the bus time and the car time are going to be the same. So the bus time is going to be its distance, which is 320, over its speed, and we can call it speed x or r or whatever. And then the car time it's going to be its distance, which is 280, over its speed. And if we say 8 minus x, that's going to say 8 miles, and then less the bus. So that's not what we want. We want the bus speed and then 8 less from that. So we want to say x minus 8. Okay? So because they're equal time, we're going to go ahead and set them equal to each other. And I don't have a lot of space, so I'm going to go ahead and do cross multiplication. You can certainly clear the fractions like we normally would, and that's going to give us the same result here. Go ahead and do the distributive property. Maybe you have to get out your calculator and punch in some numbers. Don't punch too hard, though. You don't want to break your calculator. Okay, so this is linear, and we'll go ahead and subtract 320x from both sides. And we'll migrate up here. Negative 2560 equals negative 40x, and then we'll divide both sides by negative 40, and we get the bus speed is 64 miles per hour. Okay. So we did a number of these in class. A lot of them were linked up with the same amount of time was the setup, and then we just had to find all the information and plug it in. Okay, so what do we got going on the next one? Let's speed it up a little bit. So we got 2 sprinklers. One takes 3 hours. The other one takes 6 hours, and we're assuming that they're filling up the same fountain. So what happens if they're both on filling the fountain at the same time? So this is a job problem. So rate times time is going to be equal to one job. So we set up a table probably pretty similar to this in class. So 1 and 2 for sprinkler 1, sprinkler 2, and then working together. So what we do know is their time, 3 and 6. Okay. Now, if I add 3 and 6, that's going to be 9 hours, and I don't want to say that the two fountains working together takes 9 hours, because they should be working together, which should be less than 3 hours realistically. So we'll just call it t or x or whatever. And then the reciprocals of their times is going to be their rates. So we'll have 1/3, 1/6, 1 over t, and then if you multiply, well, that's going to be 1, that's going to be 1, and that's going to be 1 if you want to multiply straight across. But the equation that we want is the first sprinkler's rate plus the second sprinkler's rate is going to be equal to the together rate. So in other words, 1/3 plus 1/6 is equal to 1 over t. Okay. We'll look at the numbers first. 6 is the larger number, and 3 goes into 6, so that means it's the common denominator for the number part. And then we also have the variable t, so we got to put that on there. Common denominator is the same thing, least common multiple. So I'm going to multiply everything by 6t over 1, because everybody's a fraction, and that's going to clear our fractions. And so we'll have 2t plus t equals 6. Combine your like terms, and then divide by 3, and then it's going to take a nice number, t equals 2 hours. Typically these didn't work out as nicely, but hey, that's good nice number here, fits our scenario. So let's move on to the mixture problem. Okay. So how many gallons of a 20% salt solution, so that's what we're going to add, should be mixed with 6 gallons of a 30% salt solution? So that's what we have, and then we're going to add in an unknown amount of the 20%, and we would like to make a 22% salt solution. So we'll draw our cylinder, and so we got 30% there, and we got 6 liters of it. And then what we're going to do is we're going to add in an unknown amount of the 20%. So we'll call that x. And then if I want to find the total amount of gallons, let's say for the moment here this was 4, the total number of gallons would be 6 plus 4, which is 10 gallons. However, I don't know if that's really what I'm going to add, so I'm going to say it's 6 plus x instead. Okay, so the total number of gallons is x plus 6 or 6 plus x. Doesn't matter which order you say that in, because addition is commutative. So total gallons is x plus 6. We'll get out our mixing cups. So there they are. Alright, so 30%, 6 liters of, or 6 gallons of it, 20%, an unknown amount of gallons, 22% is what we want to make, and we have x plus 6 gallons. Okay, and then we're just going to multiply straight down, and then we got our equation. Remember, you need to convert your percentages to decimals. I guess hypothetically we could get away with not doing that here, but it's better just to convert them. Alright, so multiplying to get our pure salt. So this is our pure salt equation. We're only counting up the salt, so the salt from the 30% plus the salt from the 20% should equal the salt from the 22% salt solution. Okay, so 6 times 3 is 18, have 1 decimal place, plus 0.2x, and then we'll distribute the 0.22, so 0.22x plus 132 with 2 decimal places. This is a linear equation, so we're going to need to move the x's to the right hand side and the non-x's to the left hand side. So we have 48 cents is equal to 2 cents, and then we'll divide both sides by 2 cents, and we have x is equal to 24. So that's how many gallons of this 20% salt solution we need to add in to dilute our 30% strength down to 22% strength. Okay. All right, kind of a weird mishmash. It is a final review, so we try to sneak in as many problems as we can. So the next one is kind of its own thing. We're going to look at an exponential equation now, so changing gears from some applications. So we're going to look at 2 to the x minus, it's x plus 4, excuse me, equals 8 to the x minus 6, okay? And so the first thing to do is to look at the bases. If you can get the bases to look the same, then that's equal bases, equal exponents is easier to do than having to do a log. So we notice that 2 to the third power is 8. So we're going to go ahead and make that substitution. So 2 to the x plus 4 is equal to 2 to the third, and then to the x minus 6. And then remember, if we have a power to a power, we're going to go ahead and multiply those exponents. Okay, so that's 2 to the x plus 4 is equal to 2, and then 3 to the x minus 6. And I'm doing it this way because it's easy to only multiply the 3 and the x, and you forget the 6. I'm guilty of doing that sometimes too. So we'll put the parentheses down there, help us remember to distribute. Alright, so now we're at the equal basis, so b to the x equals b to the y, if and only if, so the double arrow, x equals y. And that's because the exponential function is a one-to-one function that we have this property that we call equal bases, equal exponents. Okay, so out pops a nice linear, x plus 4 equals 3 times the quantity x minus 6. And then go through the motions, distribute, and then get everybody, all the x's on one side of the equation there. So maybe we'll subtract an x and we'll add 18 to do that. And then we'll divide by 2, and I think we get like, I don't know, 11 or something like that as our solution here. Okay, and then you can go and you can check that one, but we don't have to worry about any extraneous solutions for the exponential function because the domain is all real numbers. Okay, so maybe we'll get another one in today. These do take quite a while to run through all the problems. The review does have 50 questions, so over the next couple of days, hopefully I get the other few videos up.